Hello, this is Mrs. Sargent, and this is lesson 7.6, Determining the Mass of Excess Reactant. This lesson is not in your Unit 7 packet, so you'll just need to take these notes on a piece of notebook paper. We did this in class if you were absent. So, the first thing that we need to do is perform all the steps to determine the limiting reactant. So this is nothing new from the lesson 7.4 when we discussed determining limiting reactants. You're going to do the exact same steps. Once you've determined the limiting reactant, you're going to calculate the mass of the excess reactant from the starting mass of the limiting reactant. This is going to be the amount of excess reactant that is needed to fully react with the given amount of the limiting reactant. We know that the limiting reactant is all going to be used up in the reaction, and so we need to know how much of the excess reactant is going to react with that. If you have more than 2 reactants, you will do this calculation for each excess reactant. And then the third step is calculate the mass of the excess reactant, taking the available, which is the given amount of the excess reactant from the question, minus what is needed to fully react, and that will give you the mass of the excess reactant that's going to be left over. So we have this problem. It says determine the limiting reactant when 25 grams of P4 reacts with 50 grams of oxygen, given the following reaction. So we have phosphorus and we have oxygen reacting, and it's going to form tetraphosphorus decoxide. So we are going to first determine our limiting reactant from these two starting masses. So we're going to start with 25 grams of P4. We need to know the molar mass of that, which is 123.9 grams for P4. That's the mass of 1 mole of P4. Then we're going to look at our chemical equation and do our mole-to-mole ratio between P4 and P4O10. So we have 1 mole of each of those. And then we need the molar mass of P4O10, which I calculated to be 283.9. So we need to take 25 times 283.9 and then divide it by 123.9. And I got a mass of 57.3 grams of P4O10. So then we're going to do the same calculation with the starting amount of 50 grams of oxygen in order to determine which one, if it's P4 or oxygen, is the limiting reactant. So the molar mass of oxygen is 32 grams per mole. And then we need to look at our chemical equation. We have 5 moles of oxygen. And we have 1 mole of P4O10. And then we're going to have 1 mole of P4O10. The molar mass is still going to be 283.9 grams. So we're going to take 50 times 283.9 and then divide it by 32 times 5. and I got a mass of 88.7 grams of P4O10. So the limiting reactant is going to be the P4. And the excess reactant will be oxygen. So now, remember we said we need to calculate the mass of excess reactant from the starting amount of the limiting reactant. So we're going to take the starting amount of our limiting reactant, which is 25 grams of P4. The molar mass is 123.9 grams of P4. That's for 1 mole of P4. There's 1 mole of P4 in the chemical equation. And we want to know what mass of the excess reactant is going to react with this starting amount. So we have to do our mole to mole ratio, 5 moles of oxygen. And then the molar mass of oxygen is 32 grams per mole. So this means we're going to take 25 times 5 times 32 and then divide it by 123.9. And I got a mass of 32.3 grams of oxygen. So now we need to take the starting amount of our excess reactant, so the 50 grams of oxygen that is available, minus the 32.3 grams of oxygen that is needed for the reaction. 50 minus 32.3 should give us 17.7 grams of oxygen, which is in excess. Okay. So you might try going back and looking at your limiting reactant practice and see if you can calculate some of the mass of the excess reactant that is left over after the reaction. You will have one question on your test. It will be a higher level question since we haven't spent much time on this. But yeah, if you have questions about this, be sure to ask me before the test. Thanks. Have a great day.